Today I'd like to talk to you about the geology of Sauk County. In front of you see a map of the Ice Age Trail, and this is going to become a 1,100-mile trail highlighting the Ice Age and the remnants of the Ice Age that has occurred multiple times, but in particular the last Ice Age was roughly 12,000 years ago. In front of me you see Rosnose Meadows, which is just beyond the south end of Devil's Lake, which has some very interesting geological features. And this is some of the things that we will be looking at today. Here is the remnants from those features. So the first thing we want to look at is Van Hise Rock, a very interesting feature that was discovered by a UW-Madison professor in the 1800s, and from Van Hise Rock he was able to make some significant deductions. Van Hise Rock was discovered by a professor from the University of Wisconsin-Madison in the 1800s. He became one of the preeminent geologists in our country, and part of it was through his studies, including Van Hise Rock. In it we can see two main vertical layers of pink quartzite and phyolitic quartzite. Van Hise fully understood complex geology of the area, and through the study of such things as Van Hise Rock, he established fundamental principles of structural geology, metamorphism, and Precambrian rocks. Here we're looking at some sandstone remnants. This is only roughly about a half a mile from Van Hise Rock. And what's interesting about this is you can see on it, if you look real closely, ripple marks. You know, just as when we go to the beach and we have the sand and the water washing up with the waves, which can cause ripple marks in the sand. This was preserved over many years ago, and you may think I'm pointing down at it, but actually this is a virtually vertical wall, which you'll see shortly, and this is a part of the Baraboo syncline. It's a depressed piece of rock that was uplifted, and the geological forces are quite amazing to when you think where this was located at one time, but with the pressure of the earth and so forth, it was uplifted, and you can see that it is quite a high wall of sandstone that was created here in the Sauk County area. Just a few steps from that sandstone wall is the remnants from a quarry. Many of the rocks here are quartzite, but there is also a mixture of sandstone. Quartzite is a metamorphosized rock from sandstone. It takes a lot of pressure and a lot of time to create sandstone. Here we're looking at a picture taken from the east bluff of Devil's Lake. Devil's Lake, a crown jewel in our state park system. We're looking at the north shore where there is a moraine that blocked off the lake, and now we're looking across the west bluff, and we're now seeing a section where there is some talus, which is a broken down rock that's from, you know, that in the winter when we have the freezing water. It's not a glacial feature, but obviously there were powerful forces even in the winter, even in areas where there weren't glaciers. And there we see a more significant moraine than was on the north shore, and this is both moraines blocked off the Devil's Lake, giving us the beautiful lake that we have today. Many of the features of the glacier did not pass through Devil's Lake, but many of the features of the lake are created due to the powerful glaciers that passed through this area roughly 10,000 years ago. Following is a pothole, which is created typically at the bottom of a river valley with strong water flowing through. This is at the top of East Bluff Woods Trail of Devil's Lake and 600 feet above the valley floor, so it took tremendous geological forces in order for this pothole to be where it is located today. This picture is just a few feet from that pothole. As you can see, we're at the top of East Bluff, and so well above the valley floor, and so you can tell that it would have taken a lot of force to get this pothole where it's located. The last glacier that passed through was roughly 12,000 years ago, and so this pothole was created long before that. They don't know exactly when, but it was well before this. But there would have been other things that would have happened here, cooling and warming and so forth, that would have caused the talus that we formed that we saw in the previous picture. Okay, now we're looking at a sign with Norman Carter Fassett. He was chairman of the Natural Areas Committee, and in 1952, Parfrey's Glen was designated Wisconsin's first state natural area. It is a spectacular gorge which is deeply cut into a sandstone conglomerate of the south flank of the Bearwood Hills. The exposed Cambria strata provides excellent opportunities for people to do geological interpretation. In here you'll see moss-covered walls that are moist from seepage, and it's very cool and shaded. It's a great place to come in the summer. The environment supports a flora more typical of a northern Wisconsin, including yellow birch, mountain maple, and red alder, and several rare plant species, including the federally threatened northern monkshood and state-threatened rounded-stemmed false foxglove. There are also threatened bird species that make their home in Parfrey's Glen, including a Cerulean warbler and the Acadian flycatcher. I saw some unusual birds in here that day, and I believe that it may have been one of those rare threatened species. I welcome you to come to Parfrey's Glen. If you do come here, you're going to have to scramble in. They used to have walks in here. They've rebuilt them twice over the last 15 years, but both times they got flooded out. And the DNR has just given up and saying if you want to come here, that's fine, but you're going to have to scramble a little bit. The Sauk County is a great place to come if you want to look at some very unusual geology in a very short period space. You can come here. Glen is only a few miles from Devil's Lake, and so you can see some really interesting geology, and it is a really great place to go if you really want to see some really neat stuff. So welcome, and I hope you can come sometime.